Hello, Miss Eaton here again. Welcome back to lesson 12, where we're going to continue to explore the simplest form in equivalent fractions. I left you with this practice activity where you had to find the equivalent fraction pairs and then identify which one was in its simplest form. Did you get the same pairings as me? Excellent, well done. Let's have a look at one of those together. Let's take 1/10 and 10 1/100ths. Did you say that 1/10 was in its simplest form? Fantastic. Perhaps we can use that stem sentence to explain why again. Did you say that 1/10 is in its simplest form because the numerator and denominator have been made as small as possible whilst keeping the proportion the same? And how have the numerator and denominator been made as small as possible? The numerator and denominator, that's right, they've been divided by the same number, which is 10. Excellent. So the numerator is 1/10 of the denominator and the denominator is 10 times the numerator. Did you find that with all of the fraction pairs? Excellent. What can you tell me about the fractions that we've identified as the simplest form there? Do you notice one that's maybe an odd one out? Yes, super, 3/4. Why? Why did you identify that as being a bit of an odd one out? Because it's not a unit fraction. And we did say, didn't we, in the previous lesson, that very often the simplest form has been reflected by a unit fraction, but it doesn't always have to be. And we're going to look at that more in this session. What did you find out about 2/10? I've left it in the middle there because I wasn't sure where to put it. Where did you put it? Did you say it was not in its simplest form or in its simplest form? It's not in its simplest form. Fantastic. And why not? Because the numerator and denominator can be divided by the same amount to make an equivalent fraction. And what is that amount? They can be divided by 2. Fantastic. And the equivalent fraction would be 1/5, which is a unit fraction again, isn't it? And that would be in its simplest form. Really well done. How did you get on with the challenge? Do you think my puppy preferred half an hour or 30/60ths of an hour for a walk? Yes, you're quite right. He decided to choose 30/60ths because he thought that would be a longer walk. What do you think? No, you're quite right. Half an hour and 30/60ths of an hour are the same amount because they're equivalent fractions. What else do you notice about 30/60ths? There are 60 minutes in an hour. Fantastic. So the denominator represents the whole has been divided into 60 equal parts, which are the minutes, and 30 of those minutes is half an hour. Really well done. I'd like you to have a look at this fraction wall and for you to tell me everything that you can about this family of equivalent fractions. So have a think back to what we did in the last session, and I'd like you to pause me now and come back and tell me everything that you notice. Did you come back? How did you get on? What did you notice about this family of equivalent fractions? Excellent. So you noticed, haven't you, that they're equivalent because they're all the same proportion of the whole. So for example, if we look at 9/12ths here, that's the same proportion of the whole as these 3/4. Brilliant. Did you notice anything else? Excellent. Yes. So for 3/4, the numerator and denominator have been kept as small as possible, but they're still the same proportion of the whole. And that vertical relationship is the same proportion as well. Did you notice what that was? Brilliant, yes. So the numerator is 3/4 of the denominator. Excellent. Could you tell me anything else that you noticed? I bet you've written down, haven't you, that, let's say it together, 3/4 is the simplest form in this family of fractions. And we met that stem sentence, didn't we, in the last session? Shall we say it again together? The simplest form in this family of fractions is 3/4. Well done. When we looked at this fraction wall in the last session, we looked at 1/4. What's the same and what's different between 1/4 and 3/4 when we look at them on this fraction wall? Yes, that's right. 1/4 was a unit fraction. And we did say that on the whole, a lot of the simplest form of fractions are unit fractions. But in this case, 3/4 is not a unit fraction. Well done. We also looked at this multiplication square, didn't we, in the last session? And we found an equivalent fraction family with the simplest form was 1/7. Really well done. And we can see that here, can't we? 1/7. Have a little look at this yellow shaded bar. And I wonder, could you pause me and write the equivalent fraction family represented by these two bars? Pause me now and have a go. How did you get on? Did you get the same family of equivalent fractions as me? Fantastic, yes. So we can say, can't we, that 5/7 is equivalent to 10/14, which is also the same proportion of the whole as 20/28, and that's the same proportion of the whole as 35/49. Why? Why are they the same proportion of the whole? What else might you have noticed? Brilliant, excellent. So you can say, can't you, that the numerator and denominator are multiplied by the same amount and the value of the fraction remains the same. Did some of you write those as examples? So for example, here, 5/7 is the same proportion of the whole as 10/14 because they've both been multiplied by 2. The numerator and denominator have been multiplied by 2. And in 15/21, the numerator and denominator have been divided or multiplied by 3. Really well done. What about 30/42? What have the numerator and denominator been multiplied or divided by? They've been multiplied by 6. Really well done. So we can see here, can't we, that this generalisation is correct. Let's say it again together. When the numerator and denominator are multiplied or divided by the same number, the value of the fraction remains the same. Excellent. Did you notice anything else about this family of fractions? Brilliant. So yes, 5/7 is the simplest form. Now, how is that different to what we saw in the previous lesson? Yes, we said the simplest form was 1/7, didn't we? So the simplest form in this family of fractions is 5/7. And we're beginning to see that a simplest form doesn't always have to be a unit fraction. Well done. Can you tell me what the simplest form is in this family of equivalent fractions? Yes, that's right. The simplest form is 2/3. Fantastic. Why is it 2/3? Can you tell me using the stem sentence that we looked at? So 2/3 is the simplest form in this family of fractions because the numerator and denominator are made as small as possible while keeping the proportion the same. And we can see, can't we, that 2/3 is the same proportion of the whole. So these are equivalent fractions. Well done. I've taken 2 of those equivalent fractions and I'd like you to tell me if what we said in the last session is still true. So we said that in the simplest form, we have scaled, do you remember that language, the numerator and denominator to make them as small as we can. Pause me now, see if that's true, and see if you can tell me anything else that you notice. Have you come back? What did you find? Is this correct? Did you agree? Yes, you did agree. So what have the numerator and denominator been scaled by to keep them as small as we can? So 6/9, the numerator and denominator have been divided by 3. Excellent, well done. And so 2/3 is the simplest form. Now we also said that in the simplest form, we make the numerator 1. Have a little look at those again. Is this true now? What do you think? No, it's not true, is it? So in the simplest form, we don't always have to make the numerator 1. So we're finding out now, aren't we, that simplest form can look very different than a unit fraction. Now we also said that in the simplest form, we are making the fractions as small as possible. And I hope you remember, we didn't agree with that, did we? Have a look at those and see, do you still disagree with that statement that we're making the fractions as small as possible? And tell me why as well. What did you think? No, that's right, we're not making the fractions any smaller, are we? The numerator and denominator are made as small as possible while keeping the proportion the same. Shall we say that one again together? The numerator and denominator are made as small as possible while keeping the proportion the same. Well done. Across this sequence of lessons, you've met the 2 generalisations at the top of this screen. I'd like us to take a moment now just to check if these are true and also for you to prove it to me. So if we take this first generalisation, let's say it together. The numerator and denominator are made as small as possible while keeping the proportion the same. and have a look at 4/5. I'd like you to pause me now, find out if this is true, and could you draw a pictorial representation to prove it? I'll see you in a moment. How did you get on? Did you say that this is true? Yes, it is, isn't it? The numerator and denominator have been kept as small as possible, and in the case of 4/5 here, the numerator and denominator are as small as possible, but they're the same proportion of the whole as these other fractions. And how did you represent that pictorially? Fantastic! Did you draw an area model like me? So here we can see the whole has been divided into 5 equal parts, and 4 of those parts is the same proportion of the whole as if I divide the whole into 20 equal parts, and then 16 of those equal parts will be the same proportion of the whole. So well done. So that generalisation is true, and you proved it. You've also met this generalisation in several of the previous lessons. Shall we read it together? When the numerator and denominator are multiplied or divided by the same number, the value of the fraction remains the same. Do you remember that one? Super. Well, you just proved to me in the last slide that 8/10 was equivalent to 4/5 because they're the same proportion of the whole, and you drew me some great area models to prove that. Do you think you can prove that the numerator and denominator have been divided by the same amount to keep the value in 4/5 the same? You might need your multiplication square now and have a look at those relationships as well. So pause me now and find out what have the numerator and denominator both been divided by. How did you get on? What did you find? What did you say the numerator and denominator have been divided by? They've been divided by 2. Fantastic. So they've been divided by 2. What did you notice looking at your multiplication squares? Did you notice that both 8 and 10 are in the 2 times tables? Great. So how else can we say that? We can also say that 8 and 10 are multiples of 2. Brilliant. And that 2, in that case, then 2 must be a factor of 8 and 10. Fantastic. Were there any other ways that you could divide the numerator and denominator and keep the value the same? No, you had to divide by 2. What I'd like you to do now is pause me and see if you can find out what the numerator and denominator for 12/15 have been divided by to keep the value the same, and then also do the same for 16/20, and use your multiplication square to use that language of multiples and see which times tables you're using to help you do that. How did you get on? Let's have a look at 12/15. What did you find the numerator and denominator had been divided by? Did you say they'd been divided by 3? Really well done. And what did you notice about 3? Yes, it's a factor of 12 and 15, isn't it? So 12 and 15 are in the 3 times tables. They are multiples of 3. And actually, we had a look at that language, didn't we, in a few lessons ago? And you said that a common factor is a factor that is shared by 2 or more numbers. So 3 is a common factor of 12 and 15. Well done. What did you find out about 16/20? What did you divide the numerator and denominator by to keep the value the same? Did you divide by 4? Really well done. Is 4 a common factor of 16 and 20? Yes, it is. Why? Why is it a common factor? Because 16 and 20 are in the 4 times tables. They're both multiples of 4. Excellent, really well done. So have we proven this generalisation? Yes. So when the numerator and denominator are multiplied or divided, in this case, by the same number, the value of the fraction remains the same. And we've used that language, haven't we, of common factors there. So perhaps we could sharpen up our generalisation and say instead, say it with me, when the numerator and denominator are multiplied or divided by the same common factor, the value of the fraction remains the same. Well done. What about these equivalent fractions? I'd like you to pause me now and have a think about everything you noticed about them. What did you find? Yes, you found that they're the same proportion of the whole because 4/12 and 1/3 are equivalent. What else did you notice? Fantastic. So the numerator and denominator have been divided by the same amount. Can you tell me what that was? They've been divided by 4. Really well done. And what else can you tell me about 4? So the numerator and denominator can both be divided by it because it is a common factor. So it's a factor of the numerator 4 and it's also a factor of the denominator 12. And we've said, haven't we, that when the numerator and denominator are multiplied or divided, in this case, by the same common factor, the value of the fraction remains the same. Brilliant. Are there any other common factors though? So 4 is a common factor of 4 and 12. And you can probably see that on your multiplication square again, can't you? So 4 and 12 are in the 4 times tables. 4 and 12 are multiples of 4. And that's why 4 is a common factor of both the numerator and denominator. Are there any other common factors? I'm just going to pause you for a moment and I'd like you to find all the other common factors. Did you find any? What did you find? Yes, fantastic. There are other common factors. And what are they? So 4 and 12 have a common factor of 1. Excellent. And they also have a common factor of 2. Fantastic. Let's have a look what happens if we divide by the different common factors. So let's divide by the common factor 1 and have a little think what happens when we divide any number by 1. So pause me and divide the numerator and denominator by 1 and tell me which equivalent fraction you get. How did you get on? What did you get? Did you find that this was equivalent to 4/12? It's in the same form, isn't it? So we can say that the fraction stays in the same form when we divide it by 1. How about if we divide it by the other common factor 2? Would you like to have a go at that? So pause me again and divide the numerator and denominator by 2 and tell me which equivalent fraction that you get. What did you get? Okay, so if we divide the numerator and denominator by 2, did you find that you got 2/6? So this is an equivalent fraction. Is it in its simplest form? No, it's not in its simplest form. How could I get it to be in its simplest form? I could divide it by 2 again. Really well done. If I divide it by 2 again, what will my fraction be? It will be 1/3. Well done. Because, why is that? Because they're the same proportion of the whole. And actually we can see again, can't we, that the numerator and denominator have been divided by the same common factor and the value of the fraction remains the same. Do you notice anything about what's different between, we divided 4/12 by 4, didn't we, in the previous slide, and we found the equivalent fraction of 1/3. We divided it by 2 and then by 2 again. Do you notice anything about that? Excellent. So dividing by 2 and then dividing by 2 again is the same as dividing by 4, isn't it? Well done. You quite rightly told me that the common factors of 4 and 12 are 1, 2 and 4. Excellent. And we could divide the numerator and denominator by any of these common factors to get an equivalent fraction. But actually, which common factor expressed 4/12 in its simplest form? Which common factor? Brilliant. You're screaming at me now, aren't you? You're screaming at me. You're saying it was 4, Miss Eaton, it was 4. You're quite right. So when we divided by 4, we expressed 4/12 in its simplest form. Can you tell me anything about the common factor 4? So have a look at 1, 2 and 4, which are the only common factors of 4 and 12. And what can you tell me about 4? Do you remember the language? It's the highest common factor, isn't it? Let's say that together. The highest common factor of the numerator and denominator is 4. Really well done. One more time. The highest common factor of the numerator and denominator is 4. We've made a lot of connections in this session. We now know how to identify a fraction in its simplest form because we know that the numerator and denominator have been kept as small as possible whilst keeping the value the same. And we now know that we can find the highest common factor of both the numerator and denominator and divide the numerator and denominator by the highest common factor to find the simplest form. So I'd like you to do that for your independent activity. I've put 6/15 there, and find all the common factors for the numerator and denominator. And then I'd like you just to prove, if you can, that when you divide by the highest common factor, it expresses it in its simplest form. And you might want to have a look at those STEM sentences because you'll be using them in the next session and seeing if you agree with what they say. And a little challenge there, thinking back to my puppy, do you think he would have wanted to go out for 45/60ths of an hour? And how could we express that in its simplest form? And does using the highest common factor help us? Well, I hope you really enjoyed our session today. I have. I really look forward to seeing you again. Bye. Bye.